Welcome to RankLens. Today, we count down the top 10 defining moments in AE history. Artificial intelligence didn't arrive yesterday. For over 70 years, brilliant minds have been building toward the future we're living right now. Every breakthrough, every single one pivots on a moment when someone proved the impossible was possible. But which milestones actually changed the game? Which innovations didn't just impress us? They reshaped the entire trajectory of AI. We've ranked the 10 defining moments that transformed artificial intelligence from pure philosophy into the most powerful technology on Earth. This is RankLens. Let's count it down. At number 10, Rosenblatt's Perceptron 1958. Before Rosenblatt, the idea of a machine learning anything was pure science fiction. Then Frank Rosenblatt built something revolutionary, the first trainable neural model. The Perceptron wasn't just theoretical. It was the first device that actually learned to classify patterns directly from data. You fed it examples. It adjusted itself, no human reprogramming required. This invention launched connectionism and founded the entire neural network research tradition that would define AI for decades to come. Modern deep neural networks, the systems powering today's AI, are direct conceptual descendants of Rosenblatt's original design. But triumph turned to tragedy. In 1969, Marvin Minsky and Seymour Papert published a devastating critique proving the perceptron's fundamental limits. That critique triggered the first major AI funding collapse in history, the first AI winter. Yet, Rosenblatt's core insight survived. Machines could learn. At number 9, Alan Turing's Computing Machinery and Intelligence, 1950. The question sounds simple now: can machines think? But in 1950, before artificial intelligence was even a named field, Turing posed this question in a research paper that would define the discipline's central mission for decades. The paper didn't just ask a philosophical riddle, it proposed something radical, an operational test. He called it the imitation game. The idea was elegant. If a machine could convince a human judge that it was human through conversation alone, then by what meaningful measure was it not thinking? Turing's genius was shifting the goalposts from philosophy to behavior. Forget biology. Forget mechanism. What matters is performance. This framework became AI's North Star. For decades, researchers chased Turing's vision building systems that could fool humans, manipulate conversation, pass tests. His paper didn't just name the field, it gave it a target. At number 8, Deep Blue defeats Kasparov, 1997. Chess was supposed to be humanity's last fortress. For centuries, it was the ultimate measure of intellectual achievement, the game that separated genius from ordinary mind. Grandmasters were treated like philosophers, their victories celebrated as triumphs of human thought itself. Then, Deep Blue changed everything. On May 11, 1997, IBM's purpose-built chess engine defeated Garry Kasparov, the reigning world champion. The world wasn't ready. Kasparov himself had beaten an earlier version of Deep Blue just the year before, in 1996, proving the machine could be fallible. But this time was different. Deep Blue proved that a machine built for a single task could surpass the world's best human specialist. It wasn't genius. It was raw computation, brute force, and hardware, and it won. The moment reframed AI itself. You don't need to understand the problem the way humans do. You just need more computing power. At number 7, GPT-3 release 2020. For years, the pattern was clear. Bigger models did slightly better work. Engineers kept scaling up, chasing marginal improvements. Then OpenAI released GPT-3. GPT-3 was the largest publicly demonstrated language model the world had ever seen. Researchers expected slow, steady progress, maybe a 5% improvement over smaller models. What they got was magic. Suddenly, GPT-3 could write essays, summarize text, answer trivia, explain physics, all without fine-tuning, without custom training for each task. The model had learned something deeper. It could solve new problems it had never seen before. This wasn't specialization. This was generalization at unprecedented scale. That discovery, that you could unlock emergent capabilities simply by scaling model size and data, became the thesis behind modern AI. It proved large language models weren't toys or research projects. They were commercial products. The API OpenAI released sparked an entire ecosystem of businesses and applications built on top of it. GPT-3 didn't just advance AI, it proved AI could be valuable. At number 6, AlphaGo defeats Lee Sedol 2016. Go was supposed to be different. Chess fell to computers. But Go was intuition, artistry. Go was the game that required human genius in the way that raw calculation could never replicate. Go's complexity is almost incomprehensible. The number of possible board positions vastly outnumbers the atoms in the observable universe. You can't brute force Go. You have to think like a human. Feel the board, anticipate possibilities, adapt mid-game. Then DeepMind's AlphaGo beat Lee Sedol, one of the world's greatest players. And it did something even more shocking. It won roughly a decade earlier than most AI experts had publicly predicted. Experts thought this was 30, 40 years away. AlphaGo proved them wrong. The win revealed that deep reinforcement learning, training an AI to learn through trial, reward, and self-play could master domains requiring human-like intuition, not just brute force calculation. AI wasn't just computing, it could think intuitively. And that changed everything. At number 5, the Dartmouth Summer Research Project on Artificial Intelligence, 1956. Before Dartmouth, artificial intelligence wasn't a thing. It was a philosophical question debated in cafes, not a field with labs, researchers, and funding. Then McCarthy, Minsky, and Claude Shannon gathered a small group of brilliant researchers for a summer workshop. That workshop's proposal was audacious. McCarthy and his co-organizers didn't call it machine philosophies or machine rationality. They named it artificial intelligence. They said, this is a solvable engineering problem, not a philosophical mystery. Build it, code it, test it. The Dartmouth Conference officially coined the term that would define decades of research. It established AI as a formal academic discipline. The organizers, McCarthy, Minsky, Shannon, each shaped AI's first decades, setting the tone for what was possible and what was worth pursuing. McCarthy's framing was revolutionary. He didn't promise consciousness or understanding. He promised engineering, solve problems, build machines. That pragmatic vision let researchers stop philosophizing and start building. Dartmouth didn't invent AI's future. It declared that the future would be engineered, not dreamed. At number 4, backpropagation popularized 1986. Neural networks were stuck. Researchers could build single-layer networks that learned simple patterns. Multi-layer networks? Impossible. The math didn't work. You couldn't train them. The field hit a wall. Then Rumelhart, Hinton, and Williams published a paper that changed everything. They didn't invent backpropagation. The math had existed in pieces for years. But they did something more important. They showed how to use it practically. Backpropagation was the first widely adopted method to train deep neural networks. It worked by calculating how each layer's errors flowed backward, allowing the network to adjust not just its outer layer, but every hidden layer inside. This meant networks could learn hierarchical representations, extracting high-level patterns directly from raw data. That sounds technical. What it meant was machines could now learn complexity. Backpropagation remains the core training algorithm behind virtually every deep learning system today, From GPT to BERT to your phone's face recognition. It's not flashy, it's the engine. Without it, the AI revolution never happens. At number 3, ChatGPT launch, 2022. On November 30th, 2022, OpenAI released ChatGPT to the public. Nothing prepared the world for what happened next. 1 million users in just 5 days. 1 million. No consumer application in history had ever reached that milestone so fast. Not social media. Not email. Not mobile apps. Nothing. ChatGPT was the first time billions of people experienced AI that could think, reason, and talk like a human. It could answer homework questions, write essays, debug code, explain quantum physics. And it did it in conversational English, not a command line interface or a specialized tool. Just chat. Within 2 months, ChatGPT had 100 million users. That milestone triggered something seismic, a global race. Google launched Bard, Meta built Llama, Microsoft integrated GPT into Bing. Every major tech company on Earth suddenly pivoted to chase what OpenAI had unleashed. ChatGPT didn't just break adoption records. It proved AI was ready for the mainstream. And the trillion-dollar investment wave that followed proved the world was ready to bet its future on it. At number 2, AlexNet wins ImageNet Challenge, 2012. Computer vision was stalling. Researchers had hit a ceiling. Deep neural networks, which seemed promising, were too slow, too hard to train, and nobody had enough data to make them work at scale. The field was stuck. Then, Alex Krizhevsky, Ilya Sutskever, and Jeffrey Hinton trained a deep convolutional neural network on GPU's graphics processors designed for video games and competed in the ImageNet Challenge. They didn't just win, they shattered the competition. AlexNet nearly halved the error rate of the previous year's best system. The computer vision world wasn't ready. It wasn't possible until, suddenly, it was. The secret wasn't a new algorithm. It was scale. GPU parallelization made training deep networks feasible. For the first time, you could throw massive compute and data at a problem and actually solve it. AlexNet proved that GPUs weren't luxuries. They were essential. That insight triggered a tsunami of investment. Universities, startups, and major tech companies pivoted toward deep learning overnight. The AI research landscape fundamentally shifted. One win, one proof of concept, and suddenly, the entire future of AI was rewritten. At number 1, the Transformer Architecture, 2017. In December 2017, Google researchers published a paper titled, "Attention is All You Need." The title was audacious, but they were right. The Transformer architecture did something revolutionary. It replaced recurrence. Traditional deep learning used recurrent networks, LSTMs, GRUs that processed language one word at a time, one time step after another. Transformers did something different. They processed all the words at once, using self-attention to figure out which words mattered most to each other. That difference sounds small. It was everything. Self-attention made training vastly faster and more parallelizable. It made learning long-term dependencies easier. It made the architecture elegant, scalable, and powerful. Every major AI system today, GPT, BERT, Gemini, Claude, runs on this architecture. BERT revolutionized natural language understanding. GPT, built on transformers, reshaped how the world thinks about AI. Foundation models, the massive, general-purpose systems that power modern AI, are direct descendants of this single architecture. The Transformer didn't just improve performance, it unified AI. One architecture, one core idea, infinite scaling. Everything you interact with that feels intelligent today, it's running on this. These 10 moments reveal something profound about AI's history. It's not a steady climb. It's a series of explosions separated by long silences. The Perceptron ignited. then winter. Turing asked the question. Decades passed. Then Deep Blue, AlphaGo, Transformers, each breakthrough opening a door that nobody could close. What ties them together? Proof of concept. Each milestone was someone proving that what experts said was impossible was actually possible. And the moment that proof existed, the field moved forward collectively. We're standing in that moment now. The Transformer is 10 years old. We've scaled it beyond imagination, and we're still discovering what it can do. The next defining moment in AI history? It's probably being built right now. The question is, what impossible thing will they prove possible next? And that's the top 10 defining moments in AI history. If you enjoyed this countdown, subscribe to RankLens for more.